Hello guys, welcome back to my YouTube channel. My name is YAHMAD. So in this video, we're going to be looking at using two's complement. So we can use two's complement to represent negative binary values. And what we do is we use the most significant bit to work out if a binary value is positive or negative. So using two's complement, we can add negative and positive numbers together. So let's have a look at these examples here. So the most significant bit is the bit on the left side with the highest value. So, in this example for the 4-bit registers, the most significant bit is going to be 8. Now, what we have here is a 0. So if we have 0, it means we're going to have a positive value. But using 2 to complement, if the most significant bit has a 1, then we're going to have a negative binary value. So let's have a look at the first example here. So the most significant bit in this example is set to 0. So we're going to have a positive value. So so we have 1 here, which is equal to 4. We have 2 zeros, so the binary value is going to be positive 4. But in this example here, the negative bit or the most significant bit has been set to 1, and also in this example here. So we know straight away using 2's complement, these binary values are going to be represented in a negative value. So how do we work this out? So it's going to be negative 8 plus, so we have 1 here, and the value of this binary bit is 4, so it's going to be plus 4. And we have 2 zeros, so there's nothing else to add. And this is going to be minus 4. Here we start again. We have 1 for the most significant bit, which we now know represents a negative value. So it's going to be negative 8, 0 for 4, plus 2, plus 1. So plus 2, which is now negative 6, plus 1, which is now negative 5. Here we have an additional bit, which is the most significant bit. Since it's been turned on, is 1, then we know this is going to be a negative value. So it's going to be minus 16 plus, so not 8, but plus 4, because we have 1 here. So this is negative 12 now, plus 2, because we have 1 again, so 10. And then plus 1, which gives us minus 9. So what if we had to convert minus 9 to binary using 2's complement? So these are the 3 steps that we need to follow. So we basically want this over here. So what we're going to do first is convert 9 into a positive binary value. So it's going to be 0 here, 8 plus 1 is 9, and then we have 0 for the 4s and 2s. The second step is we need to flip these values in here. So if it's 0 here, then we need to flip that to 1. And by having 1 here, we know automatically this is going to be a negative value, okay? We have 1 here, so we need to flip that to 0. And then we have 2 zeros, we need to flip to 1. And then this 1, we flip to a 0. So we basically have flipped the values around, okay? The last step is we need to add 1. So we just write the same values as this register, but we want to add 1. So instead of 0, we're going to have 1 instead. And you can see we have exactly the same as what we've got here. Right, let's look at some 8-bit registers now. So we need to convert minus 54 to binary and minus 98 to binary as well using 2's complement. Okay, so the first step is we need to convert 54 to positive. Okay, so 1 to 8 does not go into 54, 64 does not go into 54, okay? 32 does go into 54, and we're left with 22. 16 does go into 22, and we're left with 6. So 0 here, and a 1, 1, 0. So now the next step is to flip the values. So let's put 1 here. So this automatically now represents a negative value. So we had 0 here, we put 1 here, 1 here, 2 zeros, 1 here, 2 zeros again, and then 1. So now that we've flipped the values, now what we can do is we need to add the 1. So if I type here 1, 1, I'm just basically copying this from above. So when you get to here, you can see we had 1 here, and to add 1, I'm just going to put 1 for the 2, and for this value, we can put 0. So we have added 1. Okay, guys, let's do the same thing for minus 98. Okay, so so the first step is to convert 98 to a positive. Okay, so does 128 go into 98? The answer is no. So 98 take away 64 is 34. So we can put a 1 here. Okay, 32 goes into 34. We can put 1 here. We have 2 remainder, so we can put a 1 here. And all of these other values should be set to 0. Okay, second step is let's flip the values, and by putting in 1 in the most significant bit, we know this is going to be representing a negative value. So these are going to be flipped to zeros, and then 1s, zeros, and a 1. So let me double check if I've done this right. 1, 1, 0, 0, and then 1, 1. Yeah. Okay, and the last step is we need to add 1. So we're going to copy this, but we're just going to add 1. So 1, 0, 0, 1, 1, 1. And again, because we're adding 1, we already have 1. We can just move that 1 across to 2 and then put 0 here. Okay, guys, so that was a quick video on 2's complement. I hope that makes sense. Please check out the rest of the playlist, drop your comments below, and please share and subscribe to the channel. Thanks for your time. Bye-bye.